Um, hey, hola Barcelona. Welcome to my talk about Spring Data Neo4j. Um, I'm not sure if you're familiar with Spring Data Neo4j, the techniques that's behind it, or even Neo4j. So I want to start with some samples that you might have seen in the last years. Um, I do think they gave Neo4j a big push. These are the offshore leaks, or in particular samples here, the Penner papers and the Paradise papers. I do think that everybody in the room got the news that they were getting a lot of data from a whistleblower, and they tried to connect the data. And the problem in this case was there was so much data, they could not just put it into a relational database and search for it over hundreds of tables. So as an alternative, they choose a graph database, in particular now Neo4j, and they made it discoverable. Where are the connections? Where are the bad guys, etc. So I do think that's the most publicity use case for Neo4j, but we also have different other customers with other use cases. For example, we have banks or credit institutes. They use Neo4j for fraud detection. Even in fraud detection, you have a more or less simple pattern you can apply on the graph and search for it. And if it finds something matching in the graph, then the investigators might have a deeper look into the transactions that came there, etc. Another use case for Neo4j is a recommendation engine. So the typical Amazon sample, customer who bought this also bought this. Would you like to buy this too? And we do have several other use cases, of course. But it's all about high connected data. So we speak most of the time about more than 1 million of nodes in the graph. So that's the typical data set we have. Also more, of course, but it does not make really much sense to store a simple small graph into the graph database if you can apply it for, or can use another database in this case. But it's fun, and you should try it. So I will start with a small sample that we look at. And it's really simple to model data into Neo4j or to extract the data, because everything you have in your development planning and write it on the whiteboard, and you connect something with something, etc., will be reflected directly in your data model. And this is, in an abstract way, the same setting you have on your disk later. So Neo4j stores the data in connected with connected references. And here are some. So this is really simple. We have a superhero who's part of a team, or might be a part of a team, and he fights an enemy. And in Neo4j, we use labels. That's starting with a colon to identify nodes. You can apply several labels, but in this case, I just wanted to keep it simple. So we make stereotypes of our nodes by labeling it. For example, we have a team now, or nodes with a label team, nodes with a label hero, nodes with a label bad person. And they are all connected through these relationships. And we call this, it looks like labels, but we call it types in this case. And you can see in this really small sample also the possibilities that we can store data either on the nodes or either on the relationships. So you can nest data, etc. It looks like JSON, it is not JSON, but you could, if you see it, you would interpret it like JSON, and you could use it like JSON, but it's not really JSON. So let's put some data into our database. I skipped the properties now, for now, and put the name right into the nodes. So we do have 2 team nodes now, the Avengers and the Guardian of the Galaxy, and they are connected to one hero of the group. That's for the Avengers is Iron Man, and it's Groot for the Guardians of the Galaxy. And they both apparently fight against Thanos or Thanos. I don't know how to spell it. Yeah, how to pronounce it. But you can see it's a small graph we apply here, and it's really, really simple now to ask Neo4j questions about it. We store the data like we would do in other databases, but what I think is the best option you get out of Neo4j, if you put data in it, you do not only retrieve the data, you can find connections, find the data, or find highly related data, etc. So we also do not only store the data, but we give you the opportunity to query your data, and we use it, and we provide you with Cypher for this. And yeah, as you can see, I don't know who never saw Cypher. As you can see, it's really simple to interpret Cypher query, not even if you've never seen it before, because we have this. We have round for nodes and rectangles for the relationships, and that's pretty much it. If you only rely on querying data and you want to specify like this a pattern, this is a simple pattern. I only want to find all data. But if you want to find teams, heroes, and the bad persons, but they are all should be fighting against the same enemy, and this case is Thanos. And if I query the data in this way in the browser, for example, I will get in return a graph that pretty much looks like the data I put in. And of course, yeah, this is in the browser, in the Neo4j browser. There will be Bloom coming up in a few months that might have a more nicer representation of your nodes and more discoverable. But that's not the usual use case, that you're going to a Neo4j browser, like to a PHP MyAdmin, and put in your queries in this case. You want to write applications who work with Neo4j. And we do have several connection modes. I will come to them later again, but for now it's embedded. It's running a Neo4j instance inside your VM, right along with your application. And we do have 2 server protocols. HTTP, that was been there like, I don't know, short after the embedded mode was there. And Bolt, that was introduced 2.5 years ago, around this time, with Neo4j 3.0. And it should reduce the cost of HTTP by being a binary protocol. It's based on NetT on the server and the client side. If we speak about Java, it's the Java driver. And it is the protocol of your choice if you want to work with a server instance, in this case. And we provide several drivers for this. It's, of course, the Java driver. That's a much the best known thing for me in this ecosystem. It's the Sharp driver, the JavaScript driver, and the Python driver. Apparently, we do offer one Python driver, but there are another community driver from a Neo4j developer that is more enthusiastic. It's not nothing we plan to put on the roadmap in there. And there are more and more drivers coming up for Bolt in other languages. The current plan, let me stick to the drivers for a minute. The current plan is that we draw a line for server connectivity and server communication and the business logic in the drivers. It's implemented in C. It will be implemented in C, so several other languages will get the opportunity to use this library, so we do not have to reinvent the wheel every time again. And there are rumors in the room that there will be a Go driver, later a Rust driver if we have this basic C library. Also, the Python driver and the C# driver will then depend on the C bottom line driver. Okay, let's go further on the Java driver. If we now have a Java driver, we can query, we can use Cypher again, or the only choice we have is now to use Cypher. But we query data and get some kind of abstract node representation back, but nothing we can directly use if we want to build business application with domains, etc., or entities. And so then was the time when we now make a step to the future. We're speaking now about, in the background, about SDN4. Or if I talk about SDN, I mean Spring Data Neo4j. And with Spring Data Neo4j 4, the object graph mapper was introduced, or the Neo4j object graph mapper was introduced. There's another one from Hibernate. Sorry, but I don't have any information about this. So the idea was, in this case, to leverage the abstraction level, or leverage the abstraction from the pure Java driver that works with nodes to something you can throw in your entities. It was first based on pure the Java driver for both communication, but shortly afterwards we introduced the connection modes for all connection support for all other modes Neo4j does offer, and so this is pretty much exactly what we are now offering with OGM. It's the embedded mode, it's Bolt, and it's HTTP. But all of these drivers work in the same way over Cypher. They're just sending Cypher to the server and do not interact like the embedded. That would be the only connection mode for Spring Data Neo4j previous version 4. And it was interacting with a built-in Java API. And the problem was back then, and apparently in our times still, that people tried to upgrade from an SDN3 instance when we used the internal API and had much more power to traverse the data to the Cypher model we introduced in SDN4. So if I speak about SDN4, we pull in OGM. If I speak about SDN3 or earlier, we're strictly speaking about something like a predecessor of Spring Data Neo4j that was just interacting with this embedded API and had more power, you can call it so, but we cannot call this Java API over HTTP or Bolt. So this was a strict line we draw there back then to base every communication on Cypher. So what brings OGM with it? OGM is make heavily use of annotations. We do not have a concept of non-annotation world or the annotation world like Spring, for example. We heavily use annotations. And OGM also offers a more convenient way to configure your data connection. We'll see in a bit. And if we are using OGM, we get I would call it basic access to the database through our domains. So I can then use the typical quad operations for a domain object. But I can also still call custom Cypher. We see the samples in a few minutes, and it will do the work the name stands for, it will map all the other entities to node entities and vice versa. So let me start with a small example, even smaller example than I had before. We now cut off the enemy and look at a particular part of the graph. So we have this hero who is part of a team. And how would you model the data? Hopefully everybody can see this code, because this is the size of the code you will see in the samples later. We model it like it's more convenient than you might thought, but it looks like a JPA mapping, if you're familiar with it. But we call entities not entities, but node entities, and you will see in a second why we had to use this node entity annotation in this case. And it's also customizable, like you know from JPA. I can refer to another node label if I do not want to apply hero in this case. Per default, OGM works like JPA in the interpretation. If you customize something like the property for the superhero name, that will be mapped to name property in the graph, vice versa, if you load the data. And it's pretty straightforward to model your domain in this with OGM. So yeah, ID is some kind of boilerplate you might extract to an abstract class outside somewhere to not repeat it in every domain class you have. So if you do not want to generate your own ID, we rely on Neo4j to give us the technical ID for the node. But you should never trust your IDs. If you delete something, etc., Neo4j will find this place where you deleted the node and reuse the ID. So yeah, in a typical transaction, you're safe, but not for a long one. And I spoke about the property. I do think what's very explicit is the relationship mapping. You can define some kind of entity that might be another node entity, or the thing I come to in the next slide, and say, yeah, your relation type is exactly the name, the type we have on this arrow, and I also can define the direction. So if I want to traverse data, this supports OGM by finding the right nodes, because the graph is more complex to find in more if you try to find in more depth. So you have several paths that may lead to the same node. So we need to give OGM some hints how to search through the database, or what should it search for. So in this case, we have this part of it. It's a silly name for a class, but I just wanted to represent that we cannot only map node entities or create node entities as domain classes, but also relationships. If we want to create these relationships, we call them rich relationships in the OGM world. And it looks pretty much the same with the ID, and has a custom property like role. So a hero might be Iron Man might be the founder or co-founder of the Avengers. And now we come to something very graphy special. We have to define the entrance and the entry and the outgoing node types in this case. And as you might see, you get a circular dependency between hero and this relationship entity. So there are a small problem some users have to fight with, but we need this explicitly to know how to traverse the graph or to find your data back. And just to end up with, it's pretty simple. The team is totally unaware of an incoming connection from hero. I could model it, so I would have 2 cycles now in my domain model. That would be really bad. So the team is has only its name as a property and it's mapped. So you get this whole small chain mapped in your configuration. We see a more complex sample in in the code samples later. So let me speak about the Neo4j configuration. Most of all, we we have this data access configuration, like, hey, that's my username, that's the URL I want to connect to, etc. I select with the URL. Is a common way with the URL to define your connection mode. You do not have to tell OGM what you want to use. If you use bold as a protocol, it will use bold in your URL. If you point to a file, it will use embedded connection mode, etc. And we also offer is more like a wrapper around the pure driver, the connection pool size, encryption, and some other things I did not mention here. What's very important is to point OGM to the packages that it has to inspect to find your domain models. You do not want, in a huge application, you do not want such a mapper to scan all of your classes just to not find node entities. It's like if you do a component scan in a Spring application on the highest level, if you want to speak about levels in packages. And we also have support something like, that's the only magic in OGM. We do have this support like Hibernate does for table generation, for auto-indexing. Because in Neo4j we do not have to generate anything. We can just throw in nodes and connections. So we thought it might be a nice feature to generate something for the user. So we have auto-indexing. That means you can use an annotation to index your data or to force the creation of an index for your data. That's pretty much all for the configuration part. Now, just to see a small sample of a data access, it looks like JPA. I skipped the transaction in this case. Of course, we do support transactions, but it would be not so clean to see the samples here. So we have the save action that we have now this session factory that holds the configuration and knows how to connect to the database. And with a simple save, we can store our data. Let's assume we put something more payloadish in there, except an empty object. Then we can retrieve the data on the OGM way. So I define a class, I want to load all. I give them a D to load one. So that's pretty much all you can do besides calling Cypher. And if you, as you see in the second example, it's more explicit. You can query for object or objects through Cypher. So you can write any Cypher you want, but the data that comes back has to be interpretable to be converted into this type you get back. So you have some kind of dynamic in your queries, but it's all I would say it's all like a pure JPA access. Also, we can remove the data. So the idea was to introduce a new convenient layer on top of OGM. And what's one of the possibilities? Yeah, use the Spring framework because at this time when SDN was invented, there were some tries to generate something like a convenient data access, but it was not really there. Let me take you for a small history or short history ride. That's our co-founder, Emil. Back in 2010, he met a guy named Rod Johnson. You might know him. And they were on a conference and were talking about data access and Spring. And they came up with the idea, hey, it would be totally great to have the convenient data access and put in a nice logo that connects Spring with Neo4j. And that was the moment Spring Data Neo4j was born. But yeah, Emil, as a co-founder, has something more important to do, he tells us, than developing Spring Data Neo4j. So over the time, there were several people involved in Spring Data Neo4j. So Michael Hanger, who was in the dev role team at Neo4j, took over the project lead, and we got plenty of help from the Spring Data team, or from Pivotal, or Spring Source back in the days. And there was also a consultancy involved that were heavily developing the features in OGM and SDN. This GraphAware, the both guys were the last ones I worked with, Nicola and František. And yeah, and time went by and why. And out of the sudden, the current plan is that I'm the Spring Data Neo4j team now. I do get a new colleague in July, but most of the time I team up with Pivotal, or explicitly with the Spring Data team at Pivotal, to work together or to get some help in developing SDN. So short about me, because I did not introduce myself. I'm a software engineer at Neo4j. Obviously, I'm responsible for Spring Data Neo4j and the Neo4j OGM. And in my spare time, I'm also the co-leader of a German Java user group, Juckosfallen, Brunswick-Wolfsburg. Yeah. But that's nothing so important if you want to learn something about Spring Data Neo4j. What brings Spring Data Neo4j? Of course, first of all, people who know Spring Data know that we try to abstract from the query language. We allow it to use it, but we try to abstract your queries into the Java world, and you do not have to fight with your query language, or in this case Cypher, to get your data, if you can model it with your methods. So the most important things, that's the thing I'm talking about, you have this derived query method. There are several names for it. I call it derived query method. We derive queries from the methods you define in your interfaces. And then you have this common feeling if you ever used another Spring Data project and switch over to Spring Data Neo4j, that it works the same way, like you would expect it. But as some Spring Data projects also do, we bring in some graph specialties. I will show you in a bit. So this is a typical Spring Data Neo4j repository. We derive. Who never used Spring Data before? Great. Okay, so one person. We derive from a Neo4j repository in this case. You could use the commons repository to derive from, and we will interpret it as a graph repository, but you get more flexibility in the graph function, special graph functions if you derive from the Neo4j repository. Let's type now for our sample. We have a hero who's identified by a type long, and out of the box we do get all the quad methods. You know that, as I just saw. But the graph-specific part is, in this case, is we do have I would call it a second parameter, depth. So you could extend every method with an extra parameter, and this is the search depth. Because the graph can, as I told you, can get pretty large. And you do not want to pull in all the data of your graph and convert it to Java objects. So we have to limit it. And the default depth is 1. That means if you load one node in the graph, it will look for the other nodes that are directly connected to it and fetch them, and nothing more. If you want more, you can customize it with a depth parameter. And this might be nothing new for you in this case now, but we do support two types of methods in this. We have this custom query methods that pretty looks like the extracted graph I had before. Yeah, and it does have this, it's parameterizable in the now in development version and Spring Data, in the release train of Spring Data, Lovelace is now also the spell support in the milestone release. So you're pretty flexible what you put in for the parameters. You can put in an object and use property access in your query methods. But usually, if it's feasible, you should just rely on the functionality and the magic of Spring Data and write these derived query methods. So in practice, this simple method find by real name will look at the property. It will look if there's an existing property in the hero class, and will then generate, if it's there, generate a query for you matching exactly what you told Spring Data Neo4j. So we do have also support. You see it in samples, a custom support for some keywords that are not in all Spring Data projects. Every Spring Data project has its own list of keywords what you can put in there. So the simple one like this equals is always there, but we for example have another interpretation of contains, etc. Then you get into the specific implementations of your Spring Data data store. So what brings Spring Data Neo4j in the current versions? Spring Data Neo4j 5.0 is in the Spring Data release train K. That's the one you get when you pull in the current Spring Boot version. Spring Data 5.1 is the next version that will be connected with the release train Lovelace, like I said before. Yeah, of course. So it's more, some things are already in there. You can use them on a stable version, like the support for Spring 5. The support in Spring Boot 2, but as you might guess, you can only use Spring Data Neo4j 5 with Spring Boot 2 and not with the previous version, because the previous version was relying on Spring 4, and the whole chain of dependencies will pull in Spring 5. So you do not want to get two Spring frameworks in your project. Then you should stick with Spring Data Neo4j 4. Exactly. What we introduced with Spring Data 5 was also this schema-based loading. So we look at your domain model in your Java code and see the relationships you mapped there. And we only query this. In the previous version, in Spring Data 4, there could be the case that you store more data in the database than you query with your domain. So I don't know if this is a normal use case, but Spring Data Neo4j 4 was looking at all of your relationships and just threw it out when he passed or tried to convert it to nodes. So it was a pretty heavy performance improvement. We also introduced persistence constructor. It looks easy, but you do not have to use a default constructor anymore. So we are now better than JPA in this case. And we try to also introduce some kind of low-level Kotlin support. We are still not there. Something like immutable fields in the, or immutable fields is very difficult if we have this cycle in your class dependencies, like I showed you before. So we do not know, are there relations there, or is the node the first thing we see? So it's pretty much complicated to get there a stable version out there that will work in every case. So, but we are working on it. And yeah, as I said before, we have now spell support in the query annotation, so we're more lined up with other Spring Data projects. So yeah, and I do think Spring Data Neo4j is a good way to interact with your data, but there are also few cases where you should reconsider the choice of Spring Data Neo4j or even OGM in the back, because as you just saw, Spring Data Neo4j is more this convenient layer that instructs OGM how to work. And so this applies not only to Spring Data Neo4j but also to OGM. If you have complex custom statements in your code and you have a ton of it, and you do not really use the features or you want to avoid conversion in any case, or is this eager conversion that OGM does in your Java from the node to the Java object, you shouldn't use SDN. And if you possess a high amount of nodes, it might be pretty much the same. If you load hundreds of thousands nodes, it might be, first of all, be pretty slow because we convert everything. And in this conversion process, we more or less duplicate and extend your data because we convert this abstract nodes we, for example, get for the driver into Java objects. So we duplicate your memory consumption in this case. We might drop the nodes later, but you will get a peak. Yeah, and I think that applies to other databases too. If your domain model does not match the graph, you end up writing custom Cypher, you end up writing workarounds to convert it via, for example, query result objects, and intermediate type you can convert data to in Spring Data, and then reapply it to your original domain. So these are the cases where you should really consider your choice. Because there's no one-size-fits-all solution and no silver bullet. Yeah, for the rest of the time, yeah, fits. I would like to show you some code, simple code. But first of all, let me talk about the demo, what you will see, what you will get, and how to play around with it for yourself. First of all, I did not took the original Neo4j desktop that's available at neo4j.com, but I took the Offshore Leaks database. The Offshore Leak database is more or less a current version of Neo4j with all the offshore leak data put in. And if you start this database, it will present you with a Neo4j browser. That's a default query thing, and a Paradise Paper application for simple browsing the data or querying the data. But there's also a data descriptor that comes in handy if I want to create a sample and I do not know what entity can I expect. So we get a few node types. I can skip the whole domain-driven design ideas behind it, but I just want to map this in a sample. The officers, the intermediates, entities, address. Entity is a wonderful name for thing. The addresses and the others. And you will see it in a bit. We focus on addresses and see who is living where and was part of the leak. I'll show you in a bit. So, and if you want to create the demo, it's pretty simple. It's like, I do think every practical sample on this conference will show you this page. And you pull in Neo4j, web support and time leaf. In this particular case, because I wanted to display more data, the data more visual than in a console. So fingers crossed that everything works. Oh. So. Sorry. So I represented it in a really simple way. There's no packaging around it. I should have used more because I wanted to focus on these addresses. Addresses are interesting. If you look at the addresses in the raw data set, you get strings that might look like addresses. And I search for, but we do not, we just get addresses. And I try to search the way to enrich my data. So I thought, who knows best badly written addresses? So I ended up with Google Maps, and I called the API to get longitude and latitude. One reason was just to get a nice demo. The other reason was that we introduced with Spring Data Neo4j 3.4 now, more spatial support. And so I could use the spatial support in my queries again to find the addresses. So, and that's pretty much all this address repository does. This address repository is a derived query. It will find, okay, that's just a hint to not get the null valued addresses. It finds the resolved. It expects the property to exist on the node. It's more a marker for me. And then comes the spatial magic in there. And I try to find addresses who are in the near of a particular distance around some point. So my idea was, if I enter some city, for example, I get the point, like as a spatial representation. That's the common type from Spring Data Commons for spatial representation. I get a point, and I can throw it in and look for addresses around this point. So no custom Cypher involved in this case. And let me show you a sample for the node entity. It looks like you saw it before. We do not have this implicit conversion support for more complex types, but you have to be explicit and throw in a converter, because maybe you want to convert it another way. So we do not want to be do not want to convert it before you really know what you want to do with a data type. And there's this resolved marker I used just to let it run through Google Maps to get the addresses. So pretty much simple. And this is the first use case I want to show you. I will look into the addresses and see how it will work. Just let me be sure that the offshore leaks graph database is started. So this is also the image you will see if you start it the first time. It will then pull in all the offshore data, etc. I can just start the database, and it will be then there. So, moment, just a moment. Hopefully I started it now. Yay, it's starting. So I created a really simple page for this. Yeah, it's starting. With the original disclaimer from the ICIJ side. So if you want to read it, or I can interpret it for you. These are not the bad persons we will see. They might be the bad persons, but they are only in the papers. So there were no real connection that they do illegal stuff. They did not do any illegal stuff. They only did stuff that was interesting, complex. So, for example, if I put in Barcelona like I did before, yeah, you know this. This is the fountain down the street, and will display me. I zoomed, so I don't know if this might be enough. Hey, let's go full screen. This one. So I enlarged it, as you can see in the back. So there are no bad people right here as the fountain. But if I zoom out, I would see, oh, that's the first one, the first address. So some kind of address in there. And oh, some more, and yeah, occasionally there are pretty much more addresses in there than you might have expected. But I think that's a common problem for large cities. So if you query other cities, you get the same result. And so in this case, I just pick some random address, and I can see the address. Yeah, great. So the addresses are not connected. And I looked into the data, and I saw that the addresses are always connected to an officer. So officer was a person or company who plays a role. So we don't know which role, but just to show you how easy it is to pull in this other data. We take an officer. Officer looks like same domain model with that node entities, nothing magical in there. Oops. This. If we use this relationship entity, the type is that's the type of the relationship the ICIJ is using to connect the data. And people are registered at an address, so the direction is, in this case, incoming. Oh, that's working perfectly. Just a getter to retrieve the officers. So in this case, because I told you that we will query with a default depth of 1, in this case we will get automatically the officers, because Neo4j, Neo4j will look at your domain model and your schema you defined here, and now see, oh, I have to look for the incoming registered addresses. And hopefully, so I did not modify this method. And yay! So yeah, if you might be Jose Maria Rios Rio, I'm sorry for you, but as I told, there might be just people who are in this paper, who are people that are involved in the offshore leaks, but might not have played any role that might be illegal. So, but there's a nice feature, and I do think that web presentations for spatial data are really interesting. So in this case, I looked in a radius of 10 kilometers around the center of the fountain. So this was a short impression how Spring Data Neo4j looks like when you model your data, and it's pretty easy to work with. Oh, that's my API key. So that's pretty much all you have to do if you have a not secured instance of Spring Data Neo4j running. It integrates well with its auto configuration with Spring Boot, so it generates your beans for the session factory, puts in the right configuration, so you do not have to care about more or less anything particular. You have to specify the URL or username, or enter username and password if you enable security in your Neo4j. That would be the default case, but the offshore leaks does not have security. And I think enable transaction management should be there in every Spring Data, when you use every Spring Data project. So these are the both important orientations you need to define in your configuration. You have to enable the Neo4j repositories. Where should Spring Data Neo4j look for to find the right data? And where should the entity scan take place? Just a small disclaimer, because I was lying. It will find, if you look into a higher package, then Neo4j will interpret everything as an entity. But there are historical reasons to keep this at least in the 5 branch. We tried to get rid of it in the far future, because the node entity and relationship entity are just stereotypes, and we assume every class it can find as a possible node entity entity we can save and update. So that's pretty much it. Yeah. Any? Okay. Thanks.